Yavara.
We're live.
Are we live? Wait.
Yes.
So people, good afternoon, and welcome back again to your Unacademy English channel. I believe you all are perfectly doing fine. Can you quickly let me know in the chats if all of you can hear us, if we are perfectly audible, visible to everyone? Quickly in the chats, people. Quickly in the chats. I want some fire in the chats. Yes? I want some fire in the chats. Let the chat box roll today. I want some fire in the chats. Quickly. Quickly, my dear students. Quickly. Everyone. Everyone in the chats. Yeah?
Guys, everyone means everyone.
Yeah, everyone means everyone. So, my dear students, I know you guys were desperately waiting for this particular session, which is going to be super amazing. Trust me on that. If you are starting from the scratch, from the zero, if your preparation is not up to the mark in physics, if you want to score really high from one single session, then this session is for you, right? This session is for you. And now Yavar sir is going to talk about what exactly he has planned in this particular session so that it will benefit you for sure.
So guys, we will be basically discussing all the sure shot questions as well as the concepts which have the high probability that they can be asked in the NEET. Okay, I will be starting from the scratch. Okay, if you haven't studied these chapters or topics before, you will 100% you will be able to understand each and every single.
So guys, this session, it's going to be short and precise. Let me tell you that. Maximum 3-4 hour session. Right?
2 to 3 hours.
2 to 3 hour session, and it's not only going to be the questions, it's going to be concepts plus questions.
Yeah.
So Yavar sir has come up with those concepts basically which are frequently asked in the NEET examination and will be asked in the upcoming NEET examination as well. So it's going to be concept discussion plus the question practice in the today's session.
Yes.
Perfect.
Yes.
And by the way, there is one more session scheduled today at 7 p.m. That is NEET 2024 most predictor paper. Right? That session is going to start 7 p.m. That's a combined session with all your educators. I'll be starting that session, followed by Yavar sir, followed by HSP sir, followed by Ambika ma'am. That is going to be the sequence of the today's session in which we shall be discussing some 200 questions. 100 from biology, right? 50 from physics, 50 from chemistry. If you see, last year we did one NEET 2023 most predicted paper, and majority of the questions directly, indirectly were from that particular session. So today also we are doing that particular session only for the NEET 2024 aspirants, and all the questions we have selected based on our experience, right, which we think they have got highest probability of getting into the upcoming NEET 2024 examination, right? So do join that particular session as well on priority. And Yavar sir, in this particular session, he is going to discuss the very, very important concepts of physics, which will help you to score really high when it comes to your NEET 2024 physics section. So are you all ready for it? I would want some fire in the chats, people. Let the chat box roll continuously, quickly.
And before that, guys, hit the like button because that's mandatory, okay? Mark the attendance, that's mandatory. And the session which is at 7 p.m. is super, super important. So all the people should be out there in the session. So we will be showing you what kind of questions are there that will be asked in the NEET 24 tomorrow, okay? So
are you all ready? I would want some fire in the chats, people.
Everyone
in the chats, everyone. I would want some fire in the chats. Let the chats roll. Let the chats roll and call up everyone. Whosoever is preparing for NEET 2024, I want every one of you to join this particular session. Everyone means everyone, because trust me, this is super important. And right after this, today at 7 p.m., there is one more, the most important session which is scheduled for all of you. That is NEET 2024 most predicted paper. And tomorrow at 7, it is NEET replica paper. Right? So I would want you guys to join all these sessions because they are going to be super, super, super important. And one more thing, day after tomorrow, Ambika ma'am is taking one session in which she is discussing the complete biology revision, guys. Complete biology revision. That session will be for 10-12 hours, right? So do join that as well. So are you all ready for the session then? Are you all ready for the today's session? Yes?
People hit the like button. That's super important. Everybody out there.
I can see not everyone has smashed the like. I would want every one of you to smash the like right now. Right now means right now. Yes?
Everybody, guys.
And the session is short and precise, just for 2 to 3 hours. He'll be discussing almost those concepts which will fetch you more than 80, 90 marks.
In just 2 hours only.
In just 2 hours.
Yeah.
Right? So we have taken enough of marathons. You know it. This channel is known for the marathons, 10, 12 hour marathons, right? Which I don't think any... Okay, I'm not going to talk about any other channel, right? Okay. Perfect, people?
Okay.
All right. So get up. Yawar sir is starting. I'm going to give him his jacket because I did not have jacket here, right?
I have
Do you want to wear the jacket?
No. I have the t-shirt.
You want this?
Yeah.
Chalo, take care, guys. See you at 7 p.m. I'll be starting that session. Okay, take care. Bye-bye. God bless you all.
All right, people. So I need to talk about something which is very important, okay? There are some people out there who actually say, there are some, I would say, kids out there who say, some people have copied our sessions, okay? Okay, who I must say basically they have been there are some teachers out there, or I say some people have said basically what we have copied their sessions, and Wasim sir was once basically I would say kind of mentor to those I would say kids out there who say we have copied their sessions, which is you guys know it. When it comes to the complete long 11 hour marathons, this team has basically given you those marathons on this particular channel. We have taught all the chapters on this particular channel, be it chemistry, be it physics, or be it biology, okay? Now, some people will say we are copying the sessions and all, okay? So, don't you think that is childish? So, let it be now, guys. So, guys, let's start this particular session over here. Make sure you subscribe to the channel and you hit the like button. And the first concept, you want to say something?
One thing I would want to add here, do tell them, is there any single academic session which they have provided on YouTube which has crossed 100K? Do ask them.
And check our marathons and check the views of our marathons, okay? Check the love that and support that you guys are showing in every single marathon, okay? Now, let's start with the first session. Everybody out there, guys, everybody out there. So, that is, we say, principle of homogeneity. This is the concept which is from I would say from units and dimensions session. Everybody out there, listen to me very, very, very carefully. Now focus, everybody over here. We say this concept actually says we cannot compare two different physical quantities, okay? This concept says we cannot compare two different physical quantities. Like if we have 4 meters over here and we say 2 kgs over here, we say we cannot add 4 meters to 2 kgs. This is illogical. This is wrong. We say 4 meters plus 2 kgs. Okay, it doesn't make any sense over here. It doesn't make any sense over here. So we say it is not possible. It is wrong. And if I say 3 meters minus 2 seconds, this is also wrong. You cannot subtract 2 seconds from 3 meters. This is also wrong. Okay, we say this is also not possible. And there is one more thing, that is, we say we cannot say 5 kg is greater than 3 meters. This is also wrong. 5 kgs. If I say I have got a rod over here, if I say I have got a rod over here, okay, so the length of the rod is, let's suppose, 5 meters. I'm saying this 5 meter is greater than 3 kgs, which this is illogical. This is wrong. Okay, we cannot do it. So if you have the same physical quantity like this 8 meters, okay, and you have got one more same physical quantity, 8 meters plus 7 meters, we can basically add these two physical quantities over here. Okay, like these two. Why? Because this is the same physical quantity. 8 plus, we say 7 is 15 meters. Like, my dear friends, if you check over here, what is the statement? Two quantities must be having same unit. dimensions which can be added or subtracted or equated. This is the principle of homogeneity. If you have got basically two quantities with the same unit, okay, same dimensions, we say we can equate, add or subtract those. Now, my dear friends, if let's suppose I say I have got two quantities, different physical quantities, can we multiply them? Yes, like we say force is equal to mass into acceleration, momentum is equal to P is equal to mv. Okay, now let's take a look over here. Let's see the question on this particular concept over here. Everybody means everybody. See, it says that if the velocity v is equal to alpha t plus beta x minus gamma xt, then find the dimensions of alpha, beta and gamma. This is the relation which is given over here. This is the relation which is given over here. This is the relation which is given over here. That is v is equal to alpha t plus we say sir beta x, then we say minus we say gamma xt. This is basically the relation which is given over here on the screen. Okay. Now it says that we have to find the dimensions of alpha, beta and gamma. Now see, as we recently studied that principle of homogeneity, what does it say? It says that we can compare, add, subtract two same physical quantities. Means. You can say this velocity is equal to this alpha t. Why? See. Here, this is added to this. This is added to this. We can only add them, we say, if they are same physical quantities over here. Okay? If they are same physical quantities over here. So we say, my dear friends, in this particular case, what we can write over here, we can write, sir, velocity is equal to alpha t. Okay? That is equal to this beta x. That is equal to this gamma xt. Why? Because we say they are the same physical quantities, dimensionally they are same. That's the reason we say we can write over here v is equal to alpha t, because they are dimensionally equal over here. That's the reason we can say this over here. Now, can I say in this particular case, if I say v is equal to alpha t, can I write over here, sir, this alpha will be simply v divided by t. And what is the dimensions of this v? This is velocity. We say it is lt minus 1 divided by we say t over here. So can I say dimensions of alpha will be simply lt minus 2 over here. These are the dimensions of alpha, that is lt minus t over here. Let me know in the chats, is this crystalline clear? Is this crystalline clear? Everybody out there, guys. Let me know in the chats, is this crystalline clear? Is this crystalline clear? Everybody. In the chats, I want all of you to give me the signal in the chats. Is this crystalline clear? Is this perfectly fine? Is this perfectly fine? Is this perfectly fine? So we say we can equate these two quantities if they are dimensionally same over here. That's the reason I'm saying v is equal to alpha t. Can I say in this particular case, we can also say v is equal to beta into x. This v is equal to beta into x. From here, you can find the value of beta, that is v divided by x. For velocity is lt minus 1. For x, we say, sir, it is L. L and L we can cancel over here. What is x? X means length. So here it will be t raised power minus 1. Similarly, you can find for this one also. That is velocity. You can say this velocity is also equal to gamma x and t. Okay. Now here can we say, sir, this gamma will be simply, that is v upon, I can say xt. So here you can say, sir, this gamma will be simply, for velocity it is lt minus 1 upon, for this it is L, and then we have got t. L and L will be cancelled. So this is t minus 2. Okay. Is this clear, guys? Let me know in the chats if this is crystalline clear to each and everyone. Is this crystalline clear to each and everyone? Everybody out there, guys, let me know in the chats. I want all of you to tell me in the chats if this is crystalline clear to each and everyone. Yes, I will be sharing the PDF. All the people out there, I will be sharing the PDF. Okay, next. If I have this particular question on the same concept over here, It says that velocity is equal to a sine x raised power x into root alpha t. Now guys, I want you guys to do one thing. You can compare this with a sine of, we say, sir, theta. It is exactly like a sine of theta. Velocity is equal to a sine of theta. Can I say in this case theta is equal to, we say theta is equal to, we say x, and then we say under root of alpha t. Yes. Now in this case we have to find the dimensions of alpha. We are comparing these two over here. Theta can be equal to this. So can I say this x will be equal? Now guys, tell me one thing. When it comes to the dimension of theta, we know, sir, theta is a dimensionless physical quantity. So I can say this is having over here, this is dimensionless, so I can write 1 over here. So this is x under root of alpha t. So this will be 1 upon x, then we say under root of alpha t over here. 1 upon x, then we say under root of alpha t. Now, if you take this over here, so can you write this is 1 upon, we say, sir, x square is equal to, we say, sir, alpha t. And then this alpha will be equal to 1 upon x square into, we say, sir, this t over here. Now, how to find the dimensions of this alpha? We can write this alpha is equal to, this will be 1 upon, this is x means length, so this will be L square, and this is time over here, this will be t. If you take this in the numerator, so this will be L raised power minus 2, t raised power minus 1. So for alpha, it is L raised power minus 2, t raised power minus 1. Hey, let me know in the chats if this is crystalline clear. And guys, if you have not liked this session yet, I want you guys to like smash the like button as soon as possible, because liking this session is very much mandatory. Everybody out there. Next concept we need to talk over here is Vernier calipers. Okay, very much important. Now guys, listen to me very carefully. When it comes to the Vernier caliper, we say this is that instrument which helps us to measure the length. Okay, so we say this Vernier caliper, it has got two scales. One is meter scale and next one is, we say, Vernier scale. As simple as that. Okay. Now, I will tell you directly over here. If let's suppose I have got a Vernier caliper, okay, and I have to, let's suppose, find the length of the rod. This is the rod over here. By using the Vernier caliper, how can we find the length of the rod? Listen to me very carefully. So this is the formula which helps us to find the length of the rod using Vernier caliper. Okay. See, I'll tell you. Length of the rod in this case will be this MSR, main scale reading. Then we say least count, and then we say Vernier scale reading. I will be telling you what is this, and this. Least count means minimum reading an instrument can take, minimum length an instrument can measure. For this Vernier caliper, we say least count is, we say 0.1. It is 0.1. Okay. 0.1 mm. Now, my dear friends, if I have to measure the length of this rod, what is the formula? We say, sir, reading will be, length will be, that is main scale reading. Then we say plus least count multiplied by Vernier scale reading. I will be telling you over here. Listen to me very carefully. Guys, this is main scale and this is Vernier scale. When it comes to the main scale reading, if I say this rod has crossed, you can see this is 1 over here. Guys, look at this. This is 1 over here. This is 1 over here. Okay, this is 1 over here. So we say this rod has crossed this 1 mm over here. Okay, it has crossed this 1. So we say in this particular case, main scale reading will be simply, that is 1. Main scale reading will be simply 1. Now least count we say 0.1. For Vernier scale, what is the minimum reading it can take? That is 0.1. Minimum length it can measure 0.1. So we write 0.1. Multiplied by, we say, Vernier scale reading, VSR. Now, how to take VSR? Now, VSR here means you have to see which number of this is coinciding with the number of this. Like, Vernier scale has got 3, which is coinciding with the 4 of meter scale. So I can say VSR in this case will be 3. If I say, let's suppose 6 was coinciding with 7, then VSR in that case is, we say, 6. So here 3 is coinciding with 4. I can say this will be simply over here. That is, we say, sir, 3. So answer in this case is 1.3 mm. This is how do we take the reading in case of Vernier calipers. First, you have to find the main scale reading, okay? Then you have to take the least count and then you have to find the Vernier scale reading. That's it. This is the formula by which you can solve all the questions from this one. Next concept we have over here, my dear friends, that is from the kinematics. That is from the kinematics. See, I say I have got over here a car. Listen to me very carefully. This car has started from rest. Very, very important. Very, very important. Very, very important. Okay. We say this car has started from rest. Means initial velocity of the car is 0. And acceleration of the car is, we say, sir, constant. Acceleration of the car is, we say, sir, constant. Okay. We say in this case, the car started from rest, acceleration is constant. I say in 1 second, after 1 second, the car is over here. In 2 seconds, the car has reached here. After 3 seconds, the car is here. After 4 seconds, the car is here. Now, my dear friends, what I'm trying to say in this particular case is that if I ask you to tell me the ratio of total displacements in 1 second, 2 second, 3 second, what does that mean? If I ask you how much is the displacement it has covered in 1 second, that is this much. If I say it is X. Second, if I say the displacement covered in 2 seconds, that will be this much. This is the displacement in 2 seconds. So it will be 4x. And displacement in 3 seconds will be 9x. Displacement in 4 seconds will be 16x. This is what we call ratio of total displacements in 1 seconds, 2 seconds, 3 seconds, 4 seconds. Okay, that will be x is to 4x is to 9x is to 16x. So you can say 1 is to 4x, 9 is to 16. You have to keep this thing in your mind. It is very, very important. There are so many questions which have been asked on this particular topic, be it JEE or be it NEET. Everybody out there, be it JEE or be it NEET. Okay, next. We say ratio of displacements in first, second, and fourths. What does this mean? I will tell you. Let's suppose, my dear friends, this car left from this particular position. What is the condition? Condition is, we say, sir, initial velocity should be 0. Acceleration should be constant. So if the car left from this point, after 1 second, the car is over here. This is the car. After 2 seconds, we say the car is over here. After 3 seconds, we say car is here. After 4 seconds, we say car is here. Guys, if I say how much is the displacement in 1 second, okay, complete 1 second, that is x, okay. And if I say how much is the displacement in, we say 2 seconds, that is this much, 4x. If I say how much is the displacement in, we say 3 seconds, that is this much. But if I tell you how much is the displacement in first second, that is this much. How much is the displacement in second, 2nd, second, that is this much. In second, it has covered this much. How much is the displacement in third second? That is this much. How much is the displacement in fourth second? That is this much. And this ratio will be x is to 3x is to 5x is to 7x. That's what we say. Ratio of displacements in first second, second, third second, fourth second, x is to 3x is to 5x is to 7x. This is the ratio in that case. Is this crystalline clear to each and everyone? Guys, if you have not liked the session yet, I want you guys to like it as soon as possible. Liking the session is mandatory. Okay? You can join my Telegram channel, that is t.me/Yawar Manzoor. Here I will be sharing all the PDFs, everything. Okay? This is my Telegram channel. You can join it. Okay? You can join it t.me/YAWARMANZOOR. Now guys, we have got a question over here. What will be the ratio of distances moved by a freely falling body in fourth and fifth second? Now see, let's suppose we have got a body over here which is released, means released initially its velocity is 0. It is released from rest. And its acceleration is, we say, sir, constant. Why? Because its acceleration is, we say, sir, acceleration due to gravity. That is g, which is constant. Okay? Okay. Now, my dear friends, if it is falling, what is the condition I have told you? If A body has got initial velocity 0, acceleration constant. In that case, if you could please tell me, sir, the ratio of the distances in first second, second second, third and fourth and so on, we say, can we say this will be the ratio? We say in that case, ratio of displacement in first second is to displacement in second second is to displacement in third second is to displacement in fourth second. Can I say this will be x is to we say 3x is to we say sir 5x is to we say sir 7x and so on. Yes. Now in this case it says that if a body falls, okay, how much will be, this is, let's suppose this is the displacement in first second, s1. This is the displacement in second second, this is s2. This is the displacement in third second, that is s3. Displacement in fourth second, that is s4. We know this will be x is to 3x is to 5x is to 7x. We are supposed to find the displacement in fourth and fifth second. Guys, in fourth second it is 7. In fifth second it will be is to 9x. So it will be 7 divided by 9. So we say s4 divided by s5 in this case will be 7 by 9. Is this clear? Is this clear? Is this clear? Similarly, there are so many questions which have been asked on this one. You can solve those questions also. I have taken this example only. Next question we have got over here. Listen to me very carefully. If you ever see a question of this sort, everybody out there, if you ever see a question of this sort, and you will be asked to find acceleration, or tension, something like this, okay? Now see, what we can do in this particular case is, if you get a question of this sort, you have one block, another block, this block, or there is another type of question which can be also made on this one. That is, if you have got, let's suppose, a table, there is a block on the table, okay? There is a pulley over here, another block is over here, and one more pulley and another block is over here, okay? Let's suppose this mass is over here, that is m1, this is, let's suppose, m2, and this is, we say, m3 in this particular case. And here also, if they ask you to find the acceleration, listen to me very carefully. How do we find the acceleration? We say in these types of questions, remember one thing, we say acceleration is net pulling force divided by, we say, net mass. This is the formula which you will be using in these questions, net pulling force by net mass. Now guys, when it comes to the net pulling force, how much is the net? See, this tension here is internal force. We don't consider this as a pulling force. We say 40 Newton will be the net pulling force. So acceleration in this case will be, we say 40, okay, will be the force over here, divided by net mass. Net mass of this system will be, we say, sir, 4 plus 6 plus 10, that will be 20. So this will be 2 meter per second square. Now, similarly over here, you can find the acceleration of this system. Guys, see, in this downward direction, if I say m3 is, we say, let's suppose 5 kg. This is, let's suppose, we say, sir, 30 kg. This is, we say, sir, 3 kgs. This is 3 kgs. Can you tell me how much is the force acting in the downward direction? We say that is m into g. M is 5, g is 10. So this will be 50 Newton. This will be, let's suppose, we say over here 30 Newton. Here, how to find acceleration? Acceleration will be net pulling force by net mass. Guys, in this case, this tension and this tension, they are the internal forces. We don't consider it. Here, net pulling force will be 50 and we say this 30. So we say that will be 50 minus 30 divided by net mass of the system. This mass plus this mass plus this mass, that is m1 plus m2 plus m3. So this will give you the acceleration in this case. Here also, net pulling force is this. In this case, net pulling force is the resultant of these two, okay, net of these two. Now, if somebody asks you find the value of this tension T1, consider, let's suppose, this block over here. Listen to me very carefully. I'll show you over here. We have got this block. What is the mass of this block? That is 4 kgs. In the forward direction, how much is the force? This is 4 kgs. And we say this is 40 Newton. and in the backward direction, we say we have got this tension. Now, acceleration already we got, that is 2 meter per second square. Because if I say acceleration here is 2 meter per second square, that is the acceleration of the entire system. And that is the acceleration of this block also, this block also, this block also. Now, guys, tell me one thing. Now, guys, tell me one thing in this particular case. Tell me one thing. We say over here, sir, use second law. Use Newton's second law. Second law. What does that say? That is net force is equal to mass times of acceleration if you have to find this tension. Okay. So we say, my dear friends, in this particular case, I can write net force will be, sir, 40 minus this t, this force minus this force is equal to mass times of acceleration. Mass is 4 kg, acceleration is 2. Now take this tension over here. 4 into 2 is 8, 40 minus 8, that is 32 will be tension. So tension in this case is, we can simply say 32 Newton. Tension in this case is simply 32 Newtons. Let me know in the chats if this is crystalline clear to each and everyone, guys. Everybody, is this crystalline clear? Is this crystalline clear? All the people out there, guys. Guys, everyone means everyone. Everyone means everyone. With the fire emojis, with the fire emojis, with the fire emojis. Is this crystalline clear to each and everyone? Okay. If you have not smashed the like button yet, I want you guys to basically smash it as soon as possible. Great, 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 great. Let's move on to this particular concept, which is also highly important. Very important. Okay. Now see, this is what we call equilibrium of suspended charges. Here, you will be given two charges over here. This is one charge and this is another charge. In this particular case, you are given two charges over here. Everybody listen to me very carefully. You are given two charges over here. Or we say two metallic spheres, two spheres. On this sphere, we say Q charge is present. On this sphere, we say Q charge is present. Now, my dear friends, what I'm trying to say in this particular case is that if I say this has got positive charge, this is also positive. And this sphere is attached to a thread. This is also attached to a thread. Tell me one thing. If the two spheres are attached to a thread, so we say they will elongate. This sphere will repel this sphere. Okay. They will basically move something like this. Okay. Now, guys, at certain position, at certain distance, they will remain at rest. They will come into equilibrium. Okay. So because of repulsion, it goes something like this, something. Now they come to rest. They will be placed something like this. So this is what we got, the equilibrium position. In this case, what are the questions that can be asked? They ask if the two charges are in equilibrium. If the two charges are in equilibrium. If the two charges are in equilibrium, everybody, then find. We say, what is the distance between the two? Find the separation between the two, x. Then find the value of charge. How much is this charge? They can ask this. Then find the value of, we say, sir, if there is a thread, in this thread you have got tension. Find the value of tension. Find the value of theta. How much is the value of this theta? At what angle they will remain at equilibrium? This is what they can ask in this type of question. Now, guys, listen to me very carefully. In order to solve this particular question, what you are supposed to do is step one is draw all the forces which are acting on the charge. If I talk about this charge, what are the forces which are acting on this particular charge? We say, sir, in the downward direction, there is a force that is what we call mg. Mg is the force which is acting in the downward direction. And there is one more force which is acting in this direction. Which one is that? That is electrostatic force, that is Fe. Why? Because this positive charge is repelling this positive charge with an electrostatic force. And we have got tension over here. If this is tension, we can say, sir, if this is theta, we say this will be T cos of theta. And this component over here will be T sine of theta. So first part is done. What you are supposed to do is draw all the forces which are acting on the body. Now guys, tell me in this particular case, everybody out there, if you are done with the forces, if you have drawn all the forces which are acting on the body, now what you are supposed to do, we say balance the forces. Balance the forces. Balance the forces. Okay, balance the forces. Now guys, tell me one thing. If the charge is in the equilibrium, means upward force is equal to downward force, this force is equal to this force. So I can say T sine of theta will be equal to electrostatic force. And we say T cos of theta will be equal to mg over here. Now, this electrostatic force is k q square divided by x square. Means between this and this, how much is the force? K q1 q2 by r square. Now, I want you guys to divide this and this equation. So T and T will be cancelled. So this will be tan of theta will be equals to, that is K Q square divided by, we say x square into mg. We say x square into mg. This is the value of theta in this particular case. This is the value of theta in this particular case. Okay. This is the value of theta in this particular case. Let me know in the chats if this is crystalline clear. Okay. Okay, done. So we got the value of theta. We got the value of theta. Now what we are supposed to calculate afterwards, call this as equation number 1. Okay. Now guys, listen to me very carefully. Now let's find the value of x. To find x. X means separation between the two charges. So we know the formula as tan of theta we recently got, that is k q square upon x square into mg. Now guys, tell me one thing. Tell me one thing in this particular case. If we got the value of this, can we say from this particular formula we can find the value of x? Yes. So take this x over here. We say, sir, this will be x square is equal to, then we say k q square upon, then we say mg, and then we say tan of theta. Then we say mg tan of theta. X square is equal to kq square upon mg tan of theta. And we can write over here x will be, that is kq square upon, we say mg tan of theta, and whole raised power we say 1 by 2. Because if you take this square over here, it will become root. Okay. Now guys, if in some question, let's suppose this theta is not given. In that case, over there, this length would be given, okay, length L, and this is x by 2. You can in that case make sine theta equal to tan theta equal to sine theta, and then you can find the value of this one. But in maximum number of cases, you'll be basically directly doing this. Next, my dear friends, what I'm trying to say in this particular case is to find, I'll write over here, to find Q. Let's find the charge. Take this equation only. I'll write as we say tan of theta will be k q square upon, we say x square mg. Okay. Now here let's find the value of q. Take it over there. So this will be x square mg. Then I'll write tan of theta, and this will be k q square. So q square will be simply equal to, that is x square mg tan of theta divided by this k. And if you write the value of this q, so we can say q is equal to, I'll write x square mg, then we say tan theta divided by, we say k, whole raised power, we say 1 by 2. Whole raised power 1 by 2. Guys, is this crystalline clear? Let me know in the chats. Let me know in the chats if this is crystalline clear to each and everyone. Is this crystalline clear, guys? And make sure you hit the like button, everybody out there. Is this crystalline clear? So we are done with the value of charge. We are done with the value of X, separation. Now, what is the last one we are supposed to find out? We say, sir, this tension T. Tell me one thing. If I say, my dear friends, I have got a charge over here that is Q. Okay. We say on this charge in the downward direction, which force is acting? That is mg. And in this direction, which force is acting? That is electrostatic force, already discussed. And in this direction, we say, sir, tension is acting. So these are the only forces which are acting on the charge, Now tell me one thing. Can I say in this particular case, guys, if I say I have got this force and this force, can you tell me what is the resultant of this one and this one? They are at 90 degrees. So I can say their resultant is simply under root of this square, that is Fe whole square, then plus this square, that is mg whole square, Okay. Now guys, tell me one thing. We say as this tension is equal to this R. Why? As if the charge is in equilibrium, can I say this force will be equal to this force? So I can say tension is equal to R is equal to under root of Fe square plus mg whole square. Is this correct? Is this clear? Is this clear to each and everyone? This will be the value of tension in this particular case, and this is how you are supposed to solve these types of problems. Hey, let me know in the chats, guys, if this is crystal and clear to each and everyone. In the chats with the fire emojis, I'm waiting for your answer, okay? In the chats, everyone means everyone. Everyone means everyone. Everyone means everyone. Let me know in the chats, guys, if this is crystal and clear. Is this crystal and clear to each and everyone? Great. Hello, it's Akib. Okay. Okay, great. Now, guys, there is another type of question which is also important, and I must say similar type of question is asked in, we say, gravitation. This type of question is asked in electrostatics as well as in gravitation. Okay, now listen to me very carefully. In this case, you are supposed to find, let's find net electric field. We have got origin over here. Okay, this is the reference point. We say from this reference point, this charge plus Q is placed at 1 meters. Then we have got this negative charge which is placed at 2 meters. Then we have got this charge which is placed at 4 meters. Then we have got this charge which is placed at 8 meters. And in this case, we are supposed to find the net electric field at this particular point. How do we exactly find the net electric field? Listen to me very carefully. I say net electric field in this case will be, guys, we say electric field because of this. That will be simply KQ divided by distance from here to here, that is 1 square is 1, KQ by R square. Because of the charge, electric field is KQ by R square. Then we say minus electric field because of this will be simply KQ divided by 2 square will be, sir, 4, KQ by 4. Then we say over here plus electric field. This is minus charge, that's why I'm taking minus over here. This is positive charge. So I'm saying this will be simply KQ divided by 4 square is, we say, 16. Then we say minus. We say KQ divided by 8 square is, we say, sir, 64. Okay, then we say plus and so on. Okay. Now, guys, tell me one thing. Can I say in this particular case, this is the electric field because of all of these charges at origin. So can I say I can take this KQ common over here? This is a very important question, guys, okay? So we say In gravitation, you will be given over here mass m. Okay. So over there, you'll be basically, you will have to find the net gravitational force at this point if you place another mass here. So we say this will be, in first it is 1 minus 1 by 4 plus 1 by 16 minus 1 by 64 plus so on. This is what we call geometric progression, that is GP. This is what we call geometric progression, that is GP. Means if you have to add all of these, there is a formula. What is that formula? S is equal to A upon 1 minus R. This is the formula that you have to use in order to add all of these. Now guys, what is A over here? A means the first term. In this case, A is, we say, 1. And here, in this particular case, my dear friends, what is R? R is what we call the common ratio. R is what we call the common ratio. Common ratio, how to find common ratio? Take any term. Let's suppose I'm taking this 1 by 16. Divide it with the term which comes before it. Then it will be minus 1 by 4. 4 ones are 4 fours are. So it will be minus 1 by 4. Let's find the sum now. Let's find the sum now. So we say sum will be A is 1 upon 1 minus 1 by 4. So it will be 1 upon. So it will be 1 plus 1 by 4. It will be 1 upon 4 into 1 is 4. 4 plus 1 is 5 divided by 4. So it will be 4 by 5. Means sum of all of this is how much? We say 4 by 5. So I write this is KQ into, we say, 4 by 5. Now what is the value of K? This is, we say, 1 upon 4 pi epsilon naught. And this is Q. And then we say 4 by 5. 4 and 4 will get cancelled. So it will be Q upon 4 pi epsilon naught. Sorry. Q upon 5 pi epsilon naught. This is the final answer in this particular case. There is another type of question which can be asked like plus charge, plus charge, plus charge, plus charge. In that case, answer will be Q by 3 pi epsilon naught. Here it is 5 pi epsilon naught. Let's move on to this one. Let's move on to this one. Let's move on to this one. Okay. Great. Now, this is the topic which you need to keep in your mind. This is the topic which you need to keep in your mind. Now, listen to me very carefully, my dear friends. Here. We say if you have got an electric field, okay, if you have got an electric field over here, and in this electric field, you are placing a dipole. And if you rotate this dipole by an angle of, we say, sir, theta, by an angle of, we say, theta. My dear friends, whenever you rotate the dipole in an electric field, means you have to do the work done, external work done. You have to rotate it. And because of that external work done, we say potential energy will be changed or potential energy will be stored in the dipole. That's this formula. Work done is equal to change in potential energy. And now, if I say because of the work done, potential energy is changed or stored in the dipole, if somebody asks you how much is that potential energy, you write that is minus P e cos theta, or that is minus P dot E. This is the concept. Now, let me show you the question over here on the same concept. See, we say if we have got an electric field over here, in this electric field, you have this dipole. Listen to me very carefully. You have this dipole. Now, this dipole is making how much angle with the x-axis? 60 degrees. Now, you are rotating this dipole, rotate it, something like this, okay? Placing it over here. Now, it is asking that find the work done in rotating the dipole from theta 1 to theta 2. What is the concept? Work done is change in potential energy. Can I use the same concept over here? So, if you do the work done, because of that work done, we say potential energy of the dipole will be changed or stored. So we say this will be U final minus U initial in this particular case. U final minus U initial in this particular case. Okay. Now tell me one thing. We say, sir, what is the potential energy? What is the value of potential energy? That is minus PE cos of theta. Guys, tell me one thing. Finally, this is the dipole over here. Finally, this is the dipole. How much angle it is making with the x-axis? That is 120 degrees over here. Because see, this is 60 degrees. Total is 180. 120 plus 60 is 180. So this will be 120. So initially the dipole is something like this. How much angle it is making? 60 degrees. So final potential energy I can write over here. Guys, see, what is the formula for potential energy? Minus PE cos theta. So I'll write minus PE cos of 120 minus this minus. Then we say initial potential energy. Initially dipole is at 60 degrees. So it will be simply, that is minus PE cos of 60 degrees. Okay. So I can write this was minus PE. Okay, this will be minus 1 by 2 cos 120. Correct me if I'm not wrong. Minus, then we say minus. I say this will be PE cos 60. That will be simply 1 by 2 over here. Minus into minus is plus. So minus into minus is plus. So this will be PE divided by 2 plus. We say this is PE divided by 2. That will be simply PE. That will be simply PE. So this is the work done in rotating the dipole from this position to this position. Hey, let me know in the chats. Let me know in the chats, everybody out there. Is this crystalline clear? Guys, I hope you have liked this particular session. Next. Okay, this concept. Okay. 6 charges plus Q minus Q. Plus Q minus Q plus Q minus Q plus Q and minus Q. This was the question which was actually asked in NEET 2022. 2022. So we say you have got the 6 charge placed something like this. And it says that there is a charge which is placed at the center. And you are taking this charge from center to infinity. You are taking this charge from center to infinity. You are taking this charge from center to, we say, infinity. Okay. And it says that how much amount of work, bring a charge from center to infinity, how much amount of work you need to do if you have to take this from center to infinity. You have to find the work done in this case. You have to find the work done in this case. You have to find the work. How much amount of work is to be done if you have to take the charge from center to infinity? Guys, what is the formula? Work done is equal to change in potential energy. Always remember this. Always remember this. Work done means change in potential energy. Directly you'll be using this formula. Guys, see. I say this work done will be final potential energy minus initial potential energy. Tell me one thing. Finally, I am saying you are taking this charge and placing it at infinity. We say at infinity, we consider potential energy as 0. Can I say final potential energy is 0? Yes. Can you tell me, initially how much is the potential energy? Guys, initially how much is the potential energy? See. Now, in case of potential energy, we check how many pairs are made. If the charge is at center initially, we say potential energy will be between this and this, 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 will be between this and this. So this is the potential energy initially. Finally, if this is at infinity, so at infinity we say it is 0. Now guys, see one thing. What I'll do in this particular case is that I say initial potential energy. That will be. Guys, how to find the potential energy between the charges? If say this is the distance d. Between these two, it will be, sir, K, Q1, let's suppose that is Q, Q2 is Q0, divided by distance is d. Okay. So between this charge and this charge, it is d. Now guys, tell me one thing. Between this charge and this charge, it is simply K, Q1, Q2 by d, because these are also the positive. Between this and this, it is also same, K, Q1, Q2 by d. So we say this is 3 times. Then you have got potential energy between this charge and this charge, negative charge and positive charge. How much that will be? That is minus K, Q, Q0 divided by d. And how many charges are over here? Negative charges, 1, 2, and 3. So we say this is also 3 times. So can I say this will cancel? So this will be also 0. So in this case, work done will be U final minus U initial, that will be simply 0. So answer in this case is 0. Okay. Next. Okay. The concept from capacitors. The concept from capacitors. The concept from capacitors. Listen to me very carefully. Listen to me very carefully, guys. Like the session. If you have not liked the session, like it as soon as possible. If let's suppose I have got a capacitor over here. This is a parallel plate capacitor. And we have placed a dielectric over here. We have placed a dielectric, another dielectric, another dielectric. K1, K2, K3, K4. Width of this is D1, width of this is D2, D3, and this is D4. And my dear friends, in this particular case, what we are supposed to do is, listen to me very carefully. We say, if we have got multiple dielectrics in between the capacitors, we say, whenever dielectric is placed between the plates, we say its capacitance changes. So here, what will be the value of new capacitance? Guys, listen to me very carefully. Epsilon naught A. Then we say D1 by K1. D1 is the width of this, K1 is its dielectric constant. D2 by K2. D3 by K3. Then we say D4 by K4. This is we say the capacitance of this capacitor in which you have got multiple dielectrics. The same question was asked in JEE Mains 2021 on the same concept. Here, you have got one dielectric, another and another. You have to find the net capacitance of this capacitor. So we say, what is the formula? C is equal to epsilon naught A divided by epsilon naught A upon. Then we say D1 by K1 plus D2 by K2 plus D3 by K3 and so on. This is the formula. Now we say C is equal to epsilon naught A. A is the area of plates. Divided by, what is the value of D1 over here? That is D. So I can write D by K plus, what is the value of this width over here? That is 2D by, we say this is 3K. 2D by 3K. 2D by 3K. Okay. Then we say plus. We say 3D by, we say 5K. Okay. Now in this particular case, what we can do is C is equal to epsilon naught A upon. We take this D by K as common. So can I write over here 1 plus, if we take D by K common, guys, D is the width of this, that is D1 by K1, D2 by K2, D3 by K3. As simple as that. Just a second, guys. Okay. So this is D by K, we can take common. Then I can write 2 by 3 plus 3 by, we say 5. What we can do in this case is C is equal to epsilon naught A upon. So this will be D by K. Then it will be 34 divided by 15. If you solve it, it will be 34 by 15. Now can we take this in the numerator? So this will be 15K epsilon naught A divided by 34D. I guess option 1 is matching. Yes. Next. This was the similar type of question which was asked in JEE Mains 2021. Now I'll tell you what does it say over here. You have got the parallel plates, okay? And it says that A dielectric in this case is placed, which has dielectric constant K. This width is given as 3D by 4. Dielectric is placed in 3D by 4. Now, how much is the remaining distance? That will be D by 4. Why? Because 3D by 4 plus D by 4 will be D. So this is air over here. In this case, you have to find the capacitance. Use the same formula. C is equal to epsilon naught A upon D. I have explained the question over here, even if the slide is not clear. Yes, we'll do the quick revision also. Don't worry about that. Guys, like this session if you have not liked this session yet. Liking this session is very much mandatory. Everybody out there. Okay. Hey, what break? We'll just finish in next 30 minutes and we are done. Okay, remember this concept also, parallel combination of the dielectrics, okay? If let's suppose you have got the dielectric slabs connected in parallel. Previously here we said dielectric slabs were in series. We say in this case, we say this is also series combination of dielectrics when the dielectrics are connected in series. Here, this is the combination of dielectrics in parallel. You have got this, they are connected in parallel. So if I say width of this is A1, A2, A3, K1, K2, K3. And if somebody asks you, this is one plate of the capacitor, this is another plate of the capacitor. If somebody asks you to find the equivalent capacitance, net capacitance here, that will be epsilon naught by D, A1, K1, A2, K2 plus A3, K3. Okay, see the question on this. You have got the two slabs over here. Here this is air, its width is A by 2. This is other dielectric slab that is having the dielectric constant K. It is also A by 2. In this case, we supposed to find the, we say equivalent capacitance. We say, sir, C is equal to epsilon naught by D. Then we say A1 K1 plus we say A2 K2. This is the formula that we use. Now in this case, we can write this is epsilon naught divided by D. Then we say, what is the value of A1 over here? A by 2. And what is the value of K1 over here? That is 1, because for air, value of K is 1. Then we say plus. What is the value of A2 over here? That is A by 2. And what is the value of K2 over here? That is K. Okay. Now, in this case, you can take A by 2 as common, epsilon naught by D, and A divided by 2. And then we have 1 plus K over here. Guys, listen to me very carefully. See, I can say this is C dash. Let's call it C dash. This is the capacitance after placing the dielectric. If I say there was no dielectric placed between the capacitor, these are the two plates. Area is A, width is D. How much is the capacitance? C is equal to epsilon naught A divided by D. This is the capacitance of a parallel plate capacitor when no dielectric is placed. If you plate the slabs in parallel, then this will be the equivalent capacitance. So can I say epsilon naught A by D? Instead of this, I can write C. So I can say C dash is equal to C by 2. Then we say 1 plus K. So option 1 is matching. Next concept. Midpoint potential. Very important. Very, very important. Very important from current electricity chapter. In current electricity and electrostatics, you can expect, we say, 10 questions. Now see, let's suppose I have got a resistance over here that is R1. Here potential is V1 and resistance is R1. I have got another resistor over here. Its resistance is R3. Potential of this point is V3. Here potential is V2, resistance is R2. If I say this is the point where all the three are actually meeting, so this is what we call the common point or midpoint. So how much is the potential of this midpoint? That's what we call midpoint potential. How do we find this? We use this formula. Vm is equal to V1 by R1 plus V2 by R2 plus V3 by R3 upon 1 by R1 plus 1 by R2 plus 1 by R3. This is what we use over here. This is the formula we use in order to find the midpoint potential. Now there is a question which was asked in JEE Mains 2019 on the same concept, See. We have to find the potential of this particular point. I'll show you how do we solve it. First, I say redraw. Redraw this figure. How do you redraw this figure? Listen to me very carefully. I say if we redraw it, guys, listen to me very carefully. You have got this 10 ohm resistor, 10 ohm resistor. I say you can basically make it something like this. This is the resistance 10 ohm. See, you can interchange the position. You can place this resistance over here. You can place this resistance over here. 10 plus 10 is, we say, sir, 20. So keep it separate. Keep this separate. Middle branch is separate. So 10 plus 10 is 20. Guys, don't get confused over here. Don't say they are in parallel over here. If you basically elongate it, so it will be 10 and 10. They are in series. So 10 plus 10 is 20. And then you have got a battery over here that is 2 volts. Okay. So this is this branch. This is this side. Now come over here. In this branch, you have got, we say, 20 ohms. And you have got 4 volt battery. And then you have got this 10 and 20. If you elongate it, it becomes 10 plus 20 and it becomes 30 ohm. So you can write it something like this, 30 ohm. And we say this is 4 volt battery over here. This is 4 volt battery over here. Okay. Now guys, tell me one thing. If you have got a question of this sort, what I did is that I basically added this and this resistance separately. This and this resistance separately. Now, I say assume 0 volt potential at this point. Assuming 0 volt potential at this point will not, we say, create any difference. Let's suppose this is 0. Guys, if this is 0 volt potential here, remember, this point will be also having 0 volt because there's a straight wire. Here also, this is 0 volt, okay? Now, if this is 0, potential difference is 20. What will be the potential of this point? That is, we say, sir, 2. 2 minus 0 is 2. Like if you have got, this is 2 volt battery. If I say this point has got potential 0 volts, what is the potential of this point? I have told you many times, always remember this potential minus this potential. Let's suppose this is A. VA minus VB is always equal to this delta V, this. Now VB is given as 0. So VA minus 0 is equal to 2 volts. So VA will be how much? That is 2 volts. So this point will be having 2 volt. Okay. This is the simple logic which I have told you before also. So if this is 0, potential difference is 2. So this point will be having 2 volt. Now if this is 0, this is 4 volt. This point will be having 4. 4 minus 0 is 4. If this is 0, this point will be also having 4 volt. Now, once again, redraw this. Guys, listen to me very carefully. I can make it something like this. See, this resistance over here, this resistance, 20 ohms. I can say this is 20 ohms over here, or you can basically make it something like this. We say this is 20 ohms. This is 20. This is this. So this point has got potential 2 volts, 4 volts, 4 volts. This is 20 ohms. This is 20 ohms. This is 30 ohms. We are supposed to find the potential of this point, that is VA. Don't you think that this point A is common to this one? It is connected to this, it is connected to this, it is connected to this. Yes. So this is what we call midpoint. Now, what is the formula for midpoint potential? V1 by R1 plus V2 by R2 plus V3 by R3 upon this. So can I say in this case, Vm will be simply V1 by R1. V1 is 2 by R1 is, we say, sir, 20 plus V2 by R2. V2 is 4. R2 is, we say, sir, 20. Then we say plus V3 is 4 divided by, we say, 30. V3 by R3 upon 1 by R1. This is 1 by R1, 1 by 20 plus 1 by R2, 1 by 20 plus 1 by R3, that is 1 by 30. So if you solve it, this will come out to be 3.12 volts. So potential of this point will be simply, we say how much? That is 3.12. Hey guys, is this clear? Is this clear? Let me know in the chats, everybody out there. Okay. One more concept, that is conversion of, we say, galvanometer into ammeter. Conversion of galvanometer into ammeter. Guys, we say galvanometer is a device which measures the current, small range of currents. Okay. Now, if you have to measure large currents, we say we take ammeter, we use ammeter. So if you have to measure large currents, we use what? We use ammeter in that case. Galvanometer is a device which is used to measure the currents, small currents. If you have to measure the large currents, we use ammeter in that case. Okay. Now guys, see, if I say I have got a galvanometer over here, I have to convert this galvanometer into an ammeter. What will I do? I will connect a resistance in, see, I'll show you over here. Let's suppose I have got a galvanometer over here. This is galvanometer. I have to convert this galvanometer into an ammeter. We say this will be the shunt resistance. There is a resistance which you have to connect in parallel. This will become, this is what we call an ammeter. Now guys, listen to me very carefully. In this case, what is ammeter? Ammeter is used to measure the large currents. In this case, they will ask you to find the value of this shunt. How much is this shunt? I will tell you. See, I say, let's suppose current I is coming from this side. We say from this galvanometer, Ig is the current which flows into the galvanometer. Ig is the current which goes into the galvanometer. Galvanometer cannot take maximum current than this, then it will burn. Now, how much will be the current through this? We say I minus Ig, yes. Now tell me one thing in this particular case. If you have to find this shunt resistance, directly remember, sir, this shunt will be simply, that is Ig into G, Ig into this G. Ig is the current in the galvanometer, G is the resistance of the galvanometer. Upon, we say I minus Ig. I minus Ig is the current in the shunt. This is the value of shunt that you have to calculate. Now, let's take a look at the question. I say resistance, a galvanometer of resistance 100 ohms. Okay, I have got a galvanometer over here. This is 100 ohms. Is used to measure 10 ampere current. Means in this case, it says that Ig is 10 ampere. Find the value of shunt resistance. Now we have connected a shunt resistance in parallel. If it is connected in parallel, so that its range becomes 50 ampere, means so that it should measure how much current? We say I should be in this case 50 ampere. I should be in this case, we say 50 ampere. Now tell me how to find the value of shunt. S is equal to, we say Ig into G upon, we say I minus, we say Ig. So can I write it? What is the value of Ig here? That is 10 multiplied by. What is the value of G? G in this case is, we say, sir, 100 upon I minus Ig. I is 50, Ig is 10. 50 minus 10 is, we say, sir, 40. This 100 by 4, this will be 25 ohms. Next. Hey guys, is this clear? All of these can Mac. In your current electricity, previously they used to ask the question from potentiometer. But right now you have got potentiometer is removed. What remains over there is, we say, galvanometer and ammeter. They can ask the question from galvanometer and ammeter. Okay. 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 Now see, conversion of galvanometer into the voltmeter. Guys, remember one thing. We say voltmeter is a device which measures potential difference. It measures potential difference. Okay. Voltmeter is a device which measures potential difference. Galvanometer also measures potential difference. Now we say, how do we convert the galvanometer into a voltmeter? Now see, previously, if we have to make the galvanometer into an ammeter, we used to connect the shunt resistance in parallel. But if you have to make voltmeter from galvanometer, we say you take the galvanometer and you connect the shunt resistance in series. Okay. And we say across both of these, let's suppose potential difference is V. And Ig is the current in this galvanometer. Now tell me one thing, my dear friends. Here also we have to find the value of shunt resistance. We say shunt in this case is V divided by Ig minus G. V is the potential difference across these two divided by Ig is the current in this branch minus we say G. G is the resistance of the galvanometer. Okay. Let's see the question. Now here it says that a galvanometer of resistance 100 ohms. We have got a galvanometer over here. We have got a galvanometer over here which has got 100 ohms. Gives a full scale deflection of 30 milliampere. Okay. So we say in this, it says current in this case is we say 30 milliampere. If it is to work as a voltmeter, if we have to make this as a voltmeter, what do? We connect the shunt resistance in series. Okay. So that it should have the range of 30 volts, means it should measure how much potential difference? We say, sir, 30 volts. V should be in this case 30 volts. It should measure 30 volts. The resistance required to be added is how much should be the value of shunt? Says that we have got a galvanometer. Okay, if we convert it into a voltmeter, it should measure 30 volts potential difference. Current is this much. Galvanometer resistance is this much. What should be the value of shunt? I told you value of shunt. See, how much is the V by Ig minus G? We say V divided by Ig minus we say G. Can I say in this case shunt will be, what is the value of V? That is 30 upon. What is the value of Ig? That is 30 milliampere. So you can say this is 30 into 10 raised power minus 3 ampere. This is milliampere, okay? So minus G. G is the resistance of galvanometer, that is given as 100. So 30 and 30 will be cancelled. Take this in the numerator. So S will be 10 raised power 3 means 1000. So here it is 10 raised power minus 3. In the numerator it becomes 10 raised power plus 3. Minus we say 100, so it becomes 900 ohms. So means you have to use 900 ohms shunt over here. Then you can measure the potential difference of 30 volts. I hope this is clear. I hope this is clear. I hope this is clear. Next concept. This is the concept from magnetism. This is the concept from magnetism. Now see guys, we say force on I2 wire due to I1 wire. Listen to me very carefully. If let's suppose you have got a wire over here in which current I1 is flowing, and you have got I2 wire over here in which I2 current is flowing. This is infinitely long, okay? And the length of this is we say, sir, L. In this particular case, whenever you have the two wires placed parallel to each other, we say they apply force on each other. Hey, don't keep on spamming. I will teach class 11th also part 2, okay? I was basically not feeling well. If I have to take the class 11th part 2, that should go complete 12-hour scratch. I was not in a condition to take that long class. If I teach you guys for like 3 to 4 hours, it means it is having no value, okay? It will be having no benefit. So if I have to teach class 11th part 2 completely, I'll have to go 12 hours scratch. For that, my health condition should be proper and fine. So that's the reason I was not replying. I was not telling you when am I going to take class 11th part 2. That was the wholly and solely reason. Okay. So once I feel that I'll basically see if I can take in next 1 or 2 days class 11th part 2. Okay, I have to see if I can stand in front of you for the 12-hour scratch. What do you think? Basically standing in front of you for 12 hours, do you think it is an easy task? Okay, and then other people will come and they say they are taking they basically copy the sessions from us. Huh? We have been teaching you on this particular channel for 12 hours scratch in English language. Show me one single channel that teaches you in English language for 12 hours. Even some few Hindi channels also take those marathons for complete 12 hours. Few Hindi channels. Okay. So wait, let me finish these. So let me finish these important topics which have the probability to come in the NEET. That's the reason. Okay. Now see. So if you have got two wires placed parallel to each other in which current is flowing, we say they apply force on each other. If I say how much is the force on this wire I2 due to wire I1, this is the force. This is the force. That is mu naught I1. I1 is the current in the wire 1. I2 is the current in the wire 2 divided by 2 pi r. R is the distance between the two wires into, we say, sir, L over here. L is what? L is the length of this wire, second wire. So this is the, I'll write over here. This is the total. This is the total force on I2 wire due to I1 wire. Due to I1 wire. This is the total force on I2 wire due to I1 wire. Due to I1 wire. Okay. Okay. Now, if I ask you to tell me how much is the force per unit length, on its unit length, how much is the force? On its unit length, how much is the force? Okay. So we say force per unit length will be F divided by L. That is this force, total force, mu naught I1, I2 divided by 2 pi r into L divided by L. L will get cancelled. So this will be the force per unit length. That is mu naught I1, I2 divided by 2 pi r. Now see the question on the same concept. This was the question which was asked in NEET 2017. We have got three wires over here. I'll make over here. So this is A, this is wire A. This dot means it is coming out of the plane, out of the board. Okay. And then you have got over here, that is wire B. And you have got over here, that is wire C. And in this case, you guys are supposed to find the net force on the wire B. Net force on the wire B. See, we know in this case, current I is flowing. Here also I is flowing. Here also I is flowing. Now tell me one thing. Tell me one thing. We have to find net force on wire B. We know that, sir, this wire will apply force on this wire towards itself. Let's suppose that is F1. Don't say F1. Let's suppose that is F. Now, same current is flowing in this wire A. This will also apply the force on this wire B. That is also F, because we recently studied. Force on this wire due to this wire will be force per unit length. That is mu naught I1, I2 divided by 2 pi r. Okay. Now tell me one thing. We say, sir, if you have got two forces, angle between these two is 90 degrees. We say in this case, resultant net force you can directly say under root of 2f, because I have told you whenever the angle between the two forces is 90 degrees, in that case resultant is root 2f. And we have to find here force per unit length, not the force. So we say this will be under root of 2. What is force per unit length? That is mu naught I1, I2. Guys, if I say F means between force between this and this, or force between this and this. Mu naught I1. What is the value of I1? That is I. What is the value of I2? That is I. So mu naught I square divided by distance divided by, we say 2 pi r. R is the distance between them. So we say 2 pi. Distance between them is given as d. So it will be 2 pi d. Now what I can do in this particular case is we can multiply with root 2 and divide with root 2. So root 2 into root 2 becomes 2. Okay. So this will be 2 mu naught I square divided by 2 root 2 pi d. This and this will cancel. So it is mu naught I square divided by 2 pi and d. Just a second, guys. Okay. So this is mu naught I square divided by 2 pi d. Which option is matching in this case? Root 2 pi d. Option A. Yes. Next. Next I can basically, yes, this one. That is motional electromotive force. Remember this, guys. What is this concept? This is from the electromagnetic induction. If I say, let's suppose I have got over here a rod, okay? And this rod is placed in a magnetic field. This is the inward magnetic field over here. Length of the rod is L and it is moving with the velocity V. Remember, my dear friends, whenever the rod moves in a magnetic field, okay, with some velocity, we say EMF is generated in that rod, that is equal to BLV or BVL. This is the EMF produced in the rod which moves in a magnetic field. Okay, in this rod, EMF will be produced. Okay, so that is BLV. It is moving in the magnetic field over here. And remember, this, all the three, we say all the three, B, L, V are mutually perpendicular. All the three are mutually perpendicular. In this particular case, you can see B is inwards. Okay. Velocity is forward. B is inward, velocity is forward, and this is the length. All the three are mutually perpendicular. Okay. Now, guys, this is the question which is on the same concept. We have got a structure something like this. Let me make it over here. We have got a magnetic field over here. This is the magnetic field inward. And in this magnetic field, we have placed a structure. Let me make that structure over here. This is the structure. This is the structure. Okay. This is the structure. My dear friends, it says that the radius of this smaller, this circle is given as R, and the radius of this bigger one is given as 2R. Now, we have to find how much is the EMF being generated in this case if it is moving with a velocity V in the magnetic field B. Guys, see, this structure is actually moving in the magnetic field B with a velocity V. We say whenever the rod or something like this structure moves in a magnetic field, we say EMF is generated in that case. We say EMF is generated in that case. Guys, like the session if you have not liked, that is mandatory. We say EMF is generated in that case. And what is the formula for EMF? EMF means what? Potential difference. We say, sir, this is EMF will be simply B, L and V. Now tell me one thing. Guys, this structure is basically made up of two structures. This one and this one. It is made up of two structures. I'll make it over here. This one and we say this one. Two structures. This is also moving with velocity V. This is also moving with velocity V. Listen to me very carefully. I'll tell you something over here. If I say, I have got a magnetic field over here. If I say I have got a magnetic field over here. Okay. And in this magnetic field, if I say there is a structure which is moving something like this, let's suppose with a velocity v, and the radius of the structure is, let's suppose we say, sir, r. We say here EMF that will be developed will be simply B, L and V. Now the question is, what am I supposed to take the length of this? Shall I take this circumference? We say no, you have to take its effective length. Effective length will be join this one point with another end, one end with another end of the rod, that will be effective length. If this is R, this will be R. So we say resultant in this case will be 2R. So L effective here. So it is simply BV L effective. So that will be BV, that is 2R. Okay. Now come over here. Come over here. In this particular case, guys, listen to me very carefully. This bigger structure, can I say this is, we say, sir, 2R. So this radius will be also, we say, sir, 2R. Yes. How much is the effective length in this case? Effective length will be 4R. Now, in this case, in this structure also, how much is the effective length? From here to here, it is 2R. From here to here, this is also 2R. Here also, we say L effective is, we say 4R. Here also we say L effective is 4R. Now tell me, how much is the EMF in this case? We say EMF in this case will be BV, L effective. L effective is BV 4R. Here also it is BV 4R. Okay. Okay. Now listen to me very carefully. Listen to me very carefully. We say, guys, you might have studied one thing. What is that? If I say I have got a battery over here, we say this battery has got EMF of 20 volts. We always say, whenever we say EMF, means battery is something over there. Now, if I say this structure has got EMF BV4R, means this rod is now behaving like a battery. It is now behaving like a cell which has got this much EMF. So can I represent this structure in terms of the cell over here? So I'll make it something like this. So this is BV4R is the EMF or potential difference of the cell. And this structure also I am representing with the help of the cell. So I'll make it over here. I will make it over here. I'll make it over here. So that is BV4R. This is EMF. Now guys, clearly you can see in this case, in a closed loop, how much is the net EMF? EMF net will be, we say 0. Remember it. I have told you this in the current electricity. If you start from this point, you take this as negative. From negative to positive, take this as positive, and you take this as negative. So net EMF will be in a closed loop will be 0. Because this is BV4R, this is BV4R. So individually, how much is the EMF? We say, sir, BV4R. And we say, sir, 0. 0 is the net EMF. We were supposed to calculate the individual EMF and the net EMF in the closed loop. And let me know in the chats with the fire emojis, is this crystal and clear to each and everybody? In the chats, everybody, guys, let me know. Next concept is, and this is the last concept. Okay, there is one more after this. And this is what we call transformers from the AC chapter. This is important. Transformers. See. Guys, if you have not liked the session yet, I want you guys to like it as soon as possible. Then tomorrow also I'll be coming up with the one more session like this. Craziest session which have the maximum probability to ask in the NEET. There are some more topics. Then I'll take one more session like this. If you like the session right now. Okay. So we say transformers. We said it's a device which is used to step up or step down the voltage. Now guys, tell me one thing. You have got the transformer at your home, like you have got the refrigerator at your home. We say when the supply comes from the outside, you use the transformer basically. So this supply goes into the transformer, and then from the transformer it goes into your load. That's what we call the refrigerator or the television, whatever you have. Why do we actually use this transformer? We said to maintain or stabilize the voltage, to maintain the voltage. If I say here you have to maintain 200 volts. So we say you will be using the transformer. So if I say you'll directly connect the wire to this refrigerator, if I say large voltages, large supply is coming from the outside, it can, this system, this refrigerator will burn out. Okay. Now, if less supply is coming from the outside, this will not work. So that's the reason we use transformer. Transformer basically step ups the voltage, increases the voltage. If the supply coming from the outside is small, it will increase that. If the supply coming from the outside is less, it will increase that. If the supply is large, it will decrease that. It will basically stabilize the voltage. Okay. Now see over here. This is how does actually the transformer look like. This is how does a transformer actually look like. This is how does a transformer actually look like. Okay. See guys, we say it is a device which is used to step up or step down the alternating voltage. Guys, listen to me very carefully. Remember always, you have got a soft iron core in case of the transformer, okay? And then you connect a wire. This is what we call the primary winding, primary coil. This is connected over here. In this primary coil, you send the input current, the supply which is coming from the outside. Okay? And then we say this is the input voltage, this is the input current. And number of turns in the primary coil is how much? That is NP. Then you have got the secondary coil over here, which is connected from the another side. This is what we call the secondary coil or the secondary winding. Here you get the output voltage. This is the output voltage, and you get the output current from this side. Number of turns in the secondary coil is NS. Now guys, if somebody asks you, I am sending the supply to this transformer, that is V input supply. This is the input voltage. Tell me, how much is the output voltage that will be produced by the transformer? That will be V output is equal to V in into number of turns in secondary coil upon number of turns in primary coil. This is the important equation. And this equation also you have to remember. This is what? This is the flux produced in the secondary. What is flux? Guys, see, if I say current is entering this coil, so because of the current, magnetic field will be produced. That magnetic field will create flux here, because that magnetic field is crossing the area of the coil. So flux will be produced in the primary coil, that is phi p. And that field lines will basically then cross through the secondary coil also. So this will be the flux produced in the secondary coil. This is NS by NP. Guys, see, if somebody asks you, if flux through primary coil is phi p, flux means number of field lines crossing the surface. How much is the flux through secondary coil? You will be using this formula. If you say in a transformer, input voltage is V in, tell me how much is the output voltage. What will you say? V out is V in into NS by NP. As simple as that. Now let's take a look at the question which we have got over here. It says that the primary and secondary coil of a transformer has got 50 and 1500 turns. Number of primary turns in the primary coil is 50. Number of turns in the secondary coil is how much? We say, sir, 1500. Okay. If the magnetic flux linked with the primary coil, so phi p is given as, we say, phi naught plus 4t. Phi naught is given as constant. The output in the secondary coil will be, we are supposed to find V output in this particular case. Guys, listen to me very carefully. I want everybody of you to listen very, very, very carefully over here. See. We say, we have studied one thing, that is Faraday's law. What does Faraday's law say? It says that EMF means potential difference V. It is always equal to d phi divided by dt. Okay? d phi by dt. So means if flux through a coil is changing, it will produce voltage or EMF. So d phi by dt is change in flux. So we say change in flux is voltage. Now tell me one thing. We are given the primary flux over here, flux through the primary coil. Can we find the input voltage through the primary coil? We say, sir, V input will be simply d phi p divided by dt. If you differentiate the flux through primary coil, you'll get the input voltage. So how much that will be? That will be differentiation of this. Differentiation of phi naught. Phi naught is constant, it is 0, plus differentiation of 4t is, we say, sir, 4. So input voltage in this case is, we say, 4. Input voltage is 4. Now, you know the value of input voltage. Number of turns in the primary coil. Number of turns in the secondary coil. Can you find output voltage? Sir, output is V in into Ns divided by Np. Hey guys, this is the formula I have told you. So now how much is V in over here? 4 into number of turns in secondary coil is, we say, sir, 1500 divided by number of turns in the primary coil is, we say, sir, 50. This and this will cancel. So this will be 5 ones are 5 threes are 50, 5 zeros are 4 into 30 is how much? 4 zeros are 0, 4 threes are 12, 120 volts. So we say input voltage was, we say, 4, and we say output voltage is how much? We say 120 volts. Okay. Is this clear? Is this clear? Let me know in the chats, everybody out there. Is this clear? Is this clear, guys? Let me know in the chats out there. Is this crystalline clear? All the people out there, guys, as soon as possible. Okay. There is one more question also which was asked in NEET 2016. This is one more pattern of questions. This was the question which was asked in NEET 2016. Okay. This is a branch. This point has got potential, we say, VA. Okay. And then you have got resistance over here. You have got battery over here. This point has got potential VB. We are supposed to find the potential in this case, that is VA minus VB. This is what we are supposed to calculate. Okay. In this particular question, we are supposed to calculate VA minus VB. Let me show you how to solve this particular question. We say, select the path from A to B. Select the path from A to B. If you have to find the potential difference VA minus VB, we say select the path from A to B. So let's suppose I'm selecting the path from A to B. I can also select the path from B to A. I can also move from B to A. So if you are selecting the path from A to B, first you have to write the potential of VA, this VA as it is. Then what you are supposed to do is, then comes this resistor. Then you have to write the potential difference of this resistor. Remember, guys, when it comes to the potential difference of the resistor, how do you write it? V is equal to IR. Current in this case is 2 ampere. R is 2. We say, sir, that is 2 into 2. V is equal to 2 into 2. That is 4. So I can say potential difference in this resistor is, we say, sir, 4 volts. Potential difference in this resistor is, we say, sir, 4 volts. Okay. And always remember, current flows from higher potential to lower potential. Current flows from higher potential to lower potential. So remember, guys, if you move from higher potential to lower potential, like this is the direction of your path. If you move from higher potential to lower potential, we always take the potential drop as negative. So this will be minus 4. If you were moving from B to A, then in that case, you are moving from higher, we say, sir, lower to higher. We take then this as positive. Then comes the battery. This is the positive terminal. This is the negative terminal. Here also you are moving from positive to negative. So this will be minus 3 volt is given. Again, resistor. So this is the direction of current. So this is positive and this is negative. So we say in this case, how much is the potential difference? Current is 2 ampere. 2 into 1. V is equal to IR. 2 into 1 is 2. So this will be 2 volts and this is minus 2 volts. Finally, we reach the point B, that is VB. So we can say VA 4 minus 3 is 7, 9. So VA minus VB will come out to be 9 volts. This was the question which was asked in NEET 2016. Okay. So we are done with this particular session. These were the super important topics as well as questions for your NEET 2024. Okay. This is not a calculation. I'm just explaining over here. This is just the one line question. One line question over here. Okay. So thank you so much, guys. Okay. See you guys in the next session. And I want all of you to like this particular session and do comment afterwards how was the session, each and everything. Okay. So if you want me to come up with one more session, something like this, okay, or the greatest session of all the sessions, I'll come up tomorrow. Okay. So thank you so much. I hope you will basically comment afterwards how was the session, everything and all, and do like this particular session. So take care and bye-bye. Okay. So and don't forget to come in the evening session at 7 p.m. That is the most predicted paper. So definitely we will be showing you all the questions out there which has the highest probability to come in the NEET tomorrow. Thank you so much, guys. This was all about it. This was all about it. Take care and bye-bye. Take care and bye-bye. I hope you have liked the session. Everybody out there.